Welcome to e-Pathshala lecture series on computer science. So the paper is on visualization techniques, and today's module, that is the 30th module, we are going to look at information filtering and aggregation. Looking at the learning objectives of today's module, here in this module we try to introduce the concepts and types of filters that are being useful for information filtering. We try to learn the system model of information filtering. We will also learn about the examples that are applicable in information filtering visualization, and we will also come to know about the concepts in information aggregation. So what is information filtering? This is an abstract problem in which the information needed is stable and it is characterized by a profile. Example, a stream of documents is arriving and each must either be presented to the user or not. This has been introduced by Loon in 1958 as selective dissemination of information, and it is being named as filtering by Denning in the year 1975. Information filtering as such, it overloads the internet due to the overloading of the information. A vast amount of information of varying quality is being disseminated each and every time. There are lots of interesting things, but also lots of trash is also available in the internet. So filtering tools help the people to find the most important and the valuable information and provide only the valuable information to the end user. The goal of an information filtering system is to sort through large volumes of dynamically generated information and present the user those which are likely to satisfy the user's information requirement. In order to identify the information that satisfies the user's information requirement or interest, an information filtering or an IF system needs to acquire an information filter that, when applied to the information item, evaluates whether the item is of interest to the user or not. So thereby this information filter represents the user's interest as such. Identifying only those pieces of information that a user would find more interesting is a key question for designing an IF system. That is, the key question is on how to acquire such an information filter. Filtering information is not a new concept, nor is it one that is being limited to electronic documents. With the increasing availability of information in the electronic forum, it becomes more important and feasible to have automatic methods to filter the information. A filtering information system can be designed as being an automatic mechanism with the capacity of monitoring a continuous flow of documents and the ability to select the documents considering its relevance for a certain user or user groups according to its needs. Filtering is based on descriptions of individuals or group information preferences, which are often called as profiles. Such profile will typically represent the long-term interest. These needs of the user are represented through a profile of interest associated to the user or to the user's group. The ability to select the relevant documents is associated with the mechanism of retrieving information that calculates the value of similarity between the documents of the collection and the profiles. The documents of greater similarity with the profiles are considered important for the user or for the user's group. So this is an information filtering system. We see that we have the rated items, that is the user, the item and the value associated with the item, and then we have the unrated items wherein the user and the item alone is available without the rated value. So we try to apply a filter over it. We try to learn the interest of the user. We try to estimate the value of rating, and we try to choose the recommendations from other users who are similar to this user, and based on these recommendations, the interest as well as the estimating the value of rating, we try to give the recommendations in the form as user, the item as well as the estimated value that is being estimated based on all these things. So some of the general features of filtering are: an information filtering system is an information system that is designed for unstructured or semi-structured data as such. This contrasts with the typical database application, which involves a very structured data such as employer records. Email messages are a good example of semi-structured data in that they have well-defined header fields and an unstructured body text. So there are various types of filters that can be applied over the information that is available on the internet. These types of filter will filter out the unwanted information from the internet and provide to the user only the needed information, and finally these needed information are being visualized in certain form or the other. The various types of filters that are available are content-based filters, collaborative filters and hybrid filters. Now let us have a look at these various types of filters. First one is a content-based filter. A content-based filter makes use of the content of the information items to evaluate whether the item is of interest to the end user or not. Profiles are either in the form of user-specified keywords or rules, and they also reflect the long-term interest of the user. The user would like the system to learn the user profile rather than impose upon the user to provide one. This kind of system, content-based filters, often use or involve the application of machine learning techniques to learn the user's interest. The user's feedback can also be acquired either implicitly by observing the user or explicitly by asking the user to rate the information that is seen or provided to them. So let us have a look at this content-based filter as such. These are the documents that are rated by the orange color ones, or the documents that are rated by the user. The document with the ratings are available. The profile of the user consists of the keywords of the documents that are being viewed by the user or are of interest to the user. The phrases that appear in the documents that are being viewed are of interest by the user. Now we are going to select the documents of interest to the end user. So the documents rated by the user are given in orange color. The documents now here, these orange color represents the documents that are unrated by the user. So we now try to find out which are the documents that are of interest to the user. So we try to perform a document matching profile, and we try to recommend some of the documents and tell that these kind of documents may be of interest to the user. So this is based on the content, that is the documents that the user has already viewed based on the keywords, phrases that appear in those documents that are viewed by the user. The next one is a collaborative filters. Collaborative filters, also known as social filters, are often used in the recommendation system. A collaborative filter makes use of a database of the user preferences to find the users with similar interests. We predict whether an unseen information item is likely to be of interest to you based on how our other users have rated this kind of item. A community of users has to continuously rate whether the information they have seen is interesting to them or not. Generally, this rating is on a scale from 1, which means that it is of no interest, to 5, meaning that it is of very interesting to the end user. So this is an example of a collaborative filter. So we have the profiles of the user. This is profile of user 1, this is profile of user 2. So like that we have various profiles of users. Now we need to look at the profile of the current user. So these people, they form a community, and based on the interest of all these profiles of user 1 to user 5, we are going to predict the profile of the current user. So the documents from like-minded users' profiles are being filtered out, and those documents are given as recommended documents to the current user, basically, because all these users belong to a particular group. The next kind of filter is a hybrid filter. The goal of hybrid filter is to take the best features of each and minimize the impact of their weaknesses with the goal of outperforming each individually. Generally, they start with one type of filter, which is content-based or collaborative kind of filter, and incorporate features from the other types of filters to improve the performance of the original filter. By the name itself, we can understand that hybrid filter is a combination of, or takes the best features of each and every filter. One simple approach to develop a hybrid filter is to have the content-based and the collaborative filter each produce separate recommendation and then combine their predictions to provide a modified predicted output to the end user. There are different types of filtering that can happen in the information that is available on the web. So the filtering can either happen as an automatic filtering or it can happen as a social filtering. In the case of automatic filtering is where the computer will evaluate what is of value for the end user. In social filtering or in collaborative filtering, the tools where other people will help you to evaluate what is of most valuable to read, just like the publishers and the organization did in the society before the internet. So the other people will help you in evaluating or will help you in telling which is of interest to you. In the case of social filtering, it means that some kind of ratings are assigned to the documents. The ratings can be compared to the stars which the newspapers often assign to films or books and other customer products. But the ratings can also include categorization into subject areas or according to some kind of particular scales. Social filtering has some similarity to the filtering being done by editors, journalists and publishers, since in both cases the humans select the filtering attribute. The simplest and the most common filtering is by organization discussions, that is, which forms groups like news groups, mailing lists, forums, blogs, etc. Each group has a topic and wants only contribution within that particular topic. So sometimes the right to submit the contributions is restricted. Only members can submit the contributions. Competence control is done before accepting a new member, and the special moderators must approve the contributions before they try to distribute it. The act when a recipient selects which groups to subscribe to can thus be seen as an act of selecting a personal filter as such. The next type of filter is the thread filtering. This is another simple and common filtering method which is also called as thread filtering. A thread is a set of messages which directly or indirectly refer to each other. So people can use these threads for filtering by specifying that they want to skip reading of existing and future contributions in certain threads. In Usenet News, this functionality is known under the term kill buffer. Messages often belong to threads basically. It may then not be possible to understand a single message without seeing other messages in the same thread. A filter or search facility which only selects certain individual messages out of the threads might then not satisfy the end user. The filter must either select several items in the thread or at least make it very easy for the users when reading one or the selected message to traverse the tree up and down from this kind of messages. The next one is profiling and filtering technologies that are being used to filter out the information that is available on the internet. Most information filtering systems are based on number of key techniques that are used to describe the information, create a user profile, and create the interaction and filtering needed for a particular useful system. The key filtering technologies available are keyword vectors, n-grams, hyperlink structures, collaborative economic-based filtering, and data mining techniques. So let us have a look at all these key filtering technologies in detail. The first one is a keyword vectors. Keyword vectors are the most popular way of representing the documents and are also used to represent the user profiles. Most representations are based on a standard information retrieval technique called as a weighted vector representation technique. The document similarity and document distance to a preferred profile vector can be easily obtained by comparing the respective vectors with, for instance, the k nearest neighbor algorithm. User profiles can be obtained by determining the clusters of document vectors that are indicative for that type of information of interest to the end user. The next kind of technique that is being used as key filtering technology is an n-gram technology. What is an n-gram? An n-gram is a sequence of n letters. Typically, n is at least 3. For each n and size of alphabet, there are a finite number of letter sequence of length n and thus a fixed number of n-grams. A text can be converted to an n-gram distribution by counting the number of times each possible n-gram appears within the text. The main benefit of n-gram lies in the fact that they are less sensitive to spelling errors and that the large n-gram vector also incorporates more of the document structure as compared to the keywords. The next technology that is being used is a hyperlink structure. So using the hyperlink structure, it is possible for us to filter out and find out the profile of the users. So these hyperlink structures are graph-like representations that can be extracted especially for documents with linked structures such as web pages, mapping out the relationship between the documents and between words and near links to other documents. The structure can be exploited to filter the web pages into different categories. The next kind of technique that is being used is the collaborative and economic filtering technique. In collaborative or social filtering, it utilizes the feedbacks and the ratings from different users to filter out the irrelevant information. The information interesting for a user is gathered on the fly by using the opinions of other users with similar interest. Economic based filtering augments this idea with a cost benefit analysis on behalf of the user. It takes into consideration parameters like the piece of the document and its cost of transmission when making the filtering decisions. The last one is the data mining technique. The data mining techniques also help us in finding out the profile of users and or the interest of users. The data mining techniques can be employed to find the similarities between data entities and thus inferring that the profile of a given user might be very close to the profile of some other user, thus correlating the current customer with the previous users. So people to people correlation, example, you are like this type of customer who typically likes, or to those previous users interest like item to item correlation, example, this item you are considering is very much like these items, allows the companies to present a customer with information that he or she is likely to be interested in. So this is a very good system model of an information filtering system. So you have the user profile, you have the profile acquisition, the information need, that is the long-term information need, the selection, that is a delegated agent. So the selected documents which are going to be very dynamic in nature, you index it and keep it for other references. You have the examination and the delivery of the recommended information to the end user. Some applications of information filtering are news dissemination in a filtered manner, sharing the educational material, example Edutella. So we try to provide information to the students or provide the e-content to the students in which area or subject the students is actually interested in. Then the information alert for digital libraries. Another application of information filtering is information alert for electronic marketplaces. So we try to alert the marketplaces. So we try to alert the digital, we provide information alert for digital libraries also. Some other applications of information filtering are stock market updates. Other names for information filtering are content based filtering, adaptive information filtering, selective dissemination of information which is being provided in library and information sizes. Collaborative filtering is also called as recommender system. So these are certain examples of collaborative filtering which use the collaborative filtering approach. Amazon.com uses the recommendation system to recommend books to the end users. Yahoo Shopping uses the recommendation system to recommend the kind of objects or the kind of items that the end user may be interested in. Similarly, all e-commerce websites like eBay, EZ, Catalog City, and all the buy.com, all these e-commerce websites, they recommend to the, as and when the end user enters into these websites, they try to provide recommendations and they provide notifications to the end users based on their interest and their profile. The next one is collaborative filtering. The goal of collaborative filtering is to make the filtering decisions for an individual based on the judgments of other users. So you have various users U and you have various objects O. So we need to find out the user's interest. In adaptive information filtering system, it is a stable and long-term interest or a dynamic information. It is against a stable and long-term interest versus a dynamic information source. The system must make a delivery decision immediately as and when the document arrives. So you have the filtering system. what are the interests of that particular typical person is supposed to be understood, and based on the interest of the person, incoming documents are supposed to be filtered, and the filtered out documents are only the documents which are of interest to the end user. So some of the adaptive filtering examples. This is a description, a homicide detective and a fire nutshell which gives the rating. This is a description of the biography of sports legend which has got a rating of 3 star. There is a description of Benjamin Martin, some kind of film which gets a rating of about 2 stars. So these are certain examples of adaptive filtering which tries to use the history, previous history of the users that have, those who have already come to that particular website and those who have seen. So what to recommend? Based on the previous histories, it is possible for us to tell whether to recommend this to a particular user or not. Some of the examples of information filtering are news filtering, email filtering, filter only the legitimate emails and filter out or leave out all the spam emails, filter out the movie, book or product based on the recommendations, then literature recommenders and many others. So the definition, next one is the information aggregation. Now that we have already filtered the information that is available and provided only the useful information to the end user, finally we need to aggregate the information that is available on the www and provide the aggregated information to the end user in the form of a visual. So information aggregation is a service that tries to gather the relevant information from multiple sources to provide convenience and add value by analyzing the aggregated information for specific objectives using the internet technologies. We call the providers of this service as aggregators. Some of the characteristics of information aggregation are comparison aggregation, relationship aggregation, intra-organization and inter-organization aggregation. So the first one is a comparison aggregation. In comparison aggregation, it retrieves the information about a set of attributes for a product or a service that is being offered by many competing vendors and normalizes the information for meaningful side-by-side comparison. Shops, bots and search agents such as mysimon.com and dealtime.com offer comparison aggregation kind of services. The next one is a relationship aggregation. The relationship aggregation is used to attract customers and provide customer loyalty. Many companies are offering convenient online services such as banking and brokerage. This has in turn greatly increased the consumer choices among different service providers. So owning a close relationship with their customers is important for service-oriented businesses. The next one is the intra-organization and inter-organization aggregation. In intra-organization aggregation, we see that it can also be used as an alternative to system integration and standardization in some large organization. For example, the integration between old system and the new ones can be done through aggregation with a minimal development cost. A similar situation exists of inter-organization aggregation as well as mixtures of intra and inter-organizational information that are being aggregated. There are certain issues that arises for information aggregation. The information aggregation is raising a number of issues that are not specifically addressed in the old legal and policy regime. For example, some financial aggregators can make transactions between accounts, but they may have not been regulated as financial institutes in the US. Therefore, the liability of any transactional errors will not be clear until the Electronic Fund Transfer Act is amended to address these kind of issues. So this is one kind of issue that arises, wherein it is not possible for them to segregate or find out transactions that are being made by some kind of financial institutions which have not been regulated as such. The next one is the relationship aggregation, which involves significant amount of personal data, which will result in serious privacy concerns that also needs to be addressed as an issue. So there are certain examples of information filtering that happens in visualization. So till now we have been looking at various techniques that are used for filtering the information and providing only the filtered information or the recommended information to the end user. Not only filtering, there are various information aggregation techniques that are applied to aggregate or collect the needed information that is actually needed by the end user and provide only the needed information to the end user. In both information filtering and information aggregation, we need to see that the information that has been filtered or aggregated is not provided as such to the end user, but rather being visualized in certain form and is being provided to the end user, because the information that has been collected or filtered out is huge. So we need to filter it out and provide whatever is essential to the end user. So this is an example of filtering that happens in visualization. So we can see the success as well as the tail rate of it. So based on that, they have shown the success as well as the tail rate for certain companies in certain states with respect to the time as well as the service. This is another example of filtering in visualization. So here we can see you can set the filter values, and based on the filters, that is, so they are selecting the filters, it is showing the filters in this screen. You can select the filters, and based on the filtered values, the visual that is shown to the end user also changes. So you can select the filtered values in the filter pane, and based on that, the visualization also changes and provides only the filtered information to the end user. This is another interesting example of filtering in visualization. This is an example of aggregation in visualization. Already we have filtered the unwanted information, and we have collected only the wanted information. So this wanted information needs to be aggregated and provided to the end user in an aggregated format or in a collective format. So these are examples of aggregation and visualization. We can see the information that has been collected has been aggregated as pie charts and are being provided to the end users. So this is another example of aggregation in visualization. We can see that all the collected information are being provided in the form of in various window panes to the end user. So in the left hand side, we can see that all the information that in the down pane, we can see all the information that are being collected. So you have you try to represent the information in red color and green color, and now you try to collectively represent all the information that is being collected in the top pane, so that you can provide a full view of the information that has been collected from various sources. So this is an example of aggregation in visualization. So let us now look at the summary of whatever we have dealt with in this particular module. So in this particular module, we have looked at the concept of information filtering, the definition of information filtering, the different types of information filtering that can happen. We have also looked at various examples of filters like collaborative filters, adaptive filters, etc. We have also looked at various techniques that can be applied or attributes that can be applied to set the filter values. And then we have looked at various types of aggregations that can happen in for collecting the information from the www. And finally, we have also looked at various examples of information filtering and aggregation in visualizations as such, wherein the information that is being filtered and gathered is being presented to the end user in a visualized format. So, thank you.